Moving on. The Omron 3G3JX-AE004 motor drive has more than one multifunction output. The electromechanical relay output can also be programmed to perform numerous functions. The electromechanical relay output is still digital in nature, but it's different than the multifunction digital output P1 in that it is electromechanical in nature and can switch other external devices with different current ratings. For example, 120 volt AC control signals or even line-to-line voltage necessary for proper operation of a spring-applied electrical release friction brake solenoid. The electromechanical relay output is a single-pole double-throw transfer contact defined by three terminals: MC, the common, MA, the normally closed side, and MB, the normally open side. Note the defined states of these contacts are determined when the motor drive is powered up with the primary input terminals. We'll start by wiring up the normally open side to switch a 120 volt AC rated pilot lamp. Again, note that the electromechanical relay is switching something other than 24 volt DC signals. We'll keep P1 low side switching the same 24 volt DC pilot lamp. To wire in the 120 volt AC rated pilot lamp, we'll grab the X1 output of a 120 volt AC control transformer. The red spiraled wire serves this purpose. We'll land the red spiraled wire on the MC common terminal of the electromechanical relay. We'll come out of the normally open MB terminal. The blue spiraled wire serves this purpose. The blue spiraled wire goes into the high side of the 120 volt AC rated pilot lamp. Black spiraled wire comes out of the low side of the 120 volt AC rated pilot lamp. The black spiraled wire is landed on the grounded X2 output of a 120 volt AC control transformer. The multifunction electromechanical relay output can perform the exact same functions as multifunction digital output P1, specifically 00, run, which signals when the motor drive is in run mode, 01, the constant speed arrival signal, 03, an overload warning signal, and 05, alarm, the default setting, to name a few. The other available functions indicate other important feedback or error conditions. To configure the multifunction electromechanical relay output, a technician does so using communication parameter C026, relay output function selection. Navigate to communication parameter C026. As expected, it's in the default 05 or alarm mode. Let's decrement it to perform 00, the run function. Press enter to save this value. With both the multifunction electromechanical relay and multifunction digital output P1 performing the 00 run function, we should observe both pilot lamps switch on whenever the motor drive is in run mode, either accelerating, at constant speed, or decelerating. The difference being that the top pilot lamp is 120 volt AC rated is being high side switched by the multifunction electromechanical relay, and the bottom pilot lamp is only 24 volt DC rated and is being low side switched by the multifunction digital output P1. Let's see if this is the case. When an operator presses run, both pilot lamps executing the run function illuminate as expected. While in constant speed mode, both pilot lamps executing the run function remain illuminated. When operator presses stop, both pilot lamps executing the run function remain illuminated during the deceleration period. Only after the controlled deceleration period is ended do both pilot lamps performing the run function turn off. Let's see if we can change the function of the multifunction electromechanical relay to 01, constant speed arrival function. Navigate to communication parameter C026. Increment it to 01, constant speed arrival. Press enter to save this value. Note multifunction digital output P1 remains in 00, run mode. When an operator presses run, only the pilot lamp switched by multifunction digital output P1 executing the run function turns on as expected. While in constant speed mode, the pilot lamp switched by multifunction digital output P1 executing the run function remains illuminated, and the pilot lamp switched by the multifunction electromechanical relay executing the constant speed arrival function comes on. You can hear the characteristic click of the electromechanical relay making physical contact. When an operator presses stop, while the pilot lamp switched by multifunction digital output P1 executing the run function remains illuminated during the deceleration period, the pilot lamp switched by the multifunction electromechanical relay executing the constant speed arrival function turns off. Only after the controlled deceleration period is ended does the pilot lamp switch by multifunction digital output P1 performing the run function turn off. Given the two pilot lamps switched by two different multifunction outputs performing two different functions, may be remotely located, or perhaps signaling some other inaccessible portion of a larger system, the Omron 3G3JX-AE004 motor drive allows a means of directly monitoring the output status of both P1 and the electromechanical relay. A technician does so by navigating to the monitor or display function D006, Multifunction Output Monitor. The data display shows two indicators. The one on the right is P1. The one on the left is the electromechanical relay. Both indicators, being on the bottom half of the data display, show that both P1 and the electromechanical relay are not currently energized. When an operator presses run, the data display indicates P1 executing the run function is energized, and the electromechanical relay executing the constant speed arrival function is de-energized. While in constant speed mode, the data display indicates both P1 executing the run function and the electromechanical relay executing the constant speed arrival function are energized. When the operator presses stop, the data display indicates P1 executing the run function is energized, and the electromechanical relay executing the constant speed arrival function is de-energized. Only after the controlled deceleration period is ended does the data display indicate both P1 executing the run function and the electromechanical relay executing the constant speed arrival function are de-energized. This means of directly monitoring the status of multifunction outputs is infinitely useful for troubleshooting purposes when the output is remotely located or otherwise inaccessible. Before we bring this lecture to a close, note that not only are these two multifunction digital outputs executing different user customizable functions, it must be emphasized they're switching two different styles of electrical loads. Multifunction digital output P1 is low-side switching a 24-volt DC control signal internally generated by the motor drive, whereas the multifunction electromechanical relay is high-side switching a 120-volt AC control signal that is externally generated. Is this cool or what? The multifunction electromechanical relay output can therefore be used as an interface with other electrical loads or other systems necessitating different levels of control voltage. Perhaps nowhere is the application of a multifunction electromechanical relay more important than in coordinating the action of a spring-applied electrical release friction brake used to positively lock a de-energized motor in place. For example, consider a motor drive that needs to execute a controlled acceleration and deceleration in which applied voltage and excitation frequency is ramped over a user customizable acceleration and deceleration time for the purposes of a soft start and soft stop. However, the brake solenoid necessitates full line-to-line voltage to energize the brake solenoid to completely disengage the friction brake. The multifunction electromechanical relay output solves this voltage mismatch by simply switching the full line-to-line voltage when signaled to do so by the motor drive. I hereby present you this quick challenge. Of the functions we examined today, run, constant speed arrival, and overload warning, which function should this multifunction electromechanical relay output be assigned to fully release the spring-applied electrical release friction brake with full line-to-line voltage the moment the motor begins the acceleration period throughout the constant speed operation and keeps it disengaged until the deceleration period is ended? If you said something that rhymes with fun, you're correct. Keep in mind that the voltage and current rating of the multifunction electromechanical relay output must be taken into consideration when switching line-to-line voltage. Instead of directly making or breaking connection to full line-to-line voltage, the multifunction electromechanical relay output could indirectly do so by energizing or de-energizing the pilot coil of an appropriately rated contactor. We'll examine other deceleration and braking methods employed by motor drives in later lectures. Until then, that's about it for this short applications exercise. In conclusion, we learned to configure the two multifunction digital outputs on the Omron 3G3JX-AE004 motor drive. We learned communication parameter C021, multifunction output terminal P1 selection, changed the function of multifunction digital output P1, and that communication parameter C026, relay output function selection, changes the functions of an electromechanical relay. Either of these two multifunction digital outputs can perform the run function, the constant speed arrival signal, the overload warning signal, which signals the system or operator that the current draw is in excess of some pre-programmed value, or other warning or feedback functions. Additionally, we learned how to program communication parameter C041, overload warning level, to signal whenever current draw is in excess of this value. We also learned to directly monitor the status of the two multifunction outputs using the monitor or display function D006, multifunction output monitor. Directly monitoring the status of multifunction outputs is infinitely useful for troubleshooting purposes when the output is remotely located or otherwise inaccessible. Finally, we discussed how the multifunction electromechanical relay output can be used to switch other electrical loads like spring-applied, electric release friction brakes. Remember to review these concepts as often as you need to really drive it home. Imagine how well lab will go if you know what you're doing. Thank you very much for your attention and interest, and we'll see you again in the next lecture of our series. Remember to tell your Lazy Lab partner about this resource, and be sure to check out the Big Bad Tech channel for additional resources and updates.